Now first I will take the attendance, then I will go for the lesson. Okay, so the screen is visible to you?
Yes, sir.
So today we will discuss about the Compton effect. So in last class we discussed about the photoelectric effect. Okay, so already we discussed revised 2 times that photoelectric effect. So that's why I am not going for again. Okay, I think everyone understood that photoelectric effect. If you have any doubt means you can ask after the completion of this class. Okay, so now we are going to the Compton effect. So see here. So Compton effect. For this Compton effect also, so by using wave nature, we cannot explain the Compton effect. By using wave nature, we cannot explain the that means wave nature of the light. We cannot explain the Compton effect. That means according to the classical theory, we can't explain the Compton effect. So that's why. So based on the quantum mechanics, here we are explaining the Compton effect. That means for explaining the quantum effect, we have to Yes, due to some network problem here, it was disconnected. So again, we will start the lesson. Okay, now I will share the screen here. Yes, screen is visible, students?
Yes, sir.
Yeah. So now we will start the Compton effect here. Okay. So according to the classical theory, so what happened? Light behave like a only wave nature, only wave nature. So by using wave nature, we can't explain the Compton effect. Compton effect. So that's why according to the quantum theory, so wave behave like a. So that means light behave like a as dual nature. It's how wave as well as particle nature. So by using particle nature of the light, here also we are explaining the Compton effect. Okay. Yeah. Now, so this is the Compton scattering effect. Compton scattering effect. When light is instant on a any material, when light is instant on a any material, what happened? So that light is that means collision between the electron and light will be happen. So what happen means that if collision occurs in between the electron and so photon, that means light will act as a like a particle nature. Particle nature means we will consider like light as a photon. Okay, photon. So collision occur between the electron and photon. Electron and photon. That collision is elastic collision here. We will consider as a elastic collision. If collision will, that means it initially electron will be rest position. So photon is instant. That means collision with the electron means what happened after collision. Photon will move like this direction. So electron will move like this direction. Okay. So that means here instant initially photon have some wavelength lambda I. So final wavelength here lambda f. So there is a change of the wavelength. There is a change of the wavelength initial and final wavelength. So what is the change of the wavelength? That is as the lambda shift. Lambda shift. Okay, lambda shift wavelength shift generally we will consider. So that equal to h by mec into 1 minus cos theta. Okay, so by using this Compton experiment, we will calculate the lambda shift. We will calculate the lambda shift. Okay, so this experiment was discovered by Compton. Compton in that means his period will be 1892 to 1962. Okay, now coming to the so what we will finally able to understood from this experiment means so that means describe the Compton experiment. Okay, explain the Compton wavelength shift and describe how experiment with the X-rays confine the particle nature of the radiation. Okay, from this Compton effect, so we can observe these all things here. Okay, so that means if you will take atom, so in that atom inside nucleus will be there, electrons are revolving around that nucleus. So like this, so this is the three-dimensional view of the electron revolving around the nucleus here. Okay, now statement of the Compton effect. A.H. Compton observed that when monochromatic beam of high frequency, so will only here we have to observe high frequency. So by using high frequency of the light, we will do this experiment. Okay, so what is the difference between photoelectric effect and Compton effect? Anyone, can you explain? So in case of photoelectric effect, so whatever the light incident on the metal plate, so that light is absorbed, total light is absorbed by the that metal plate. That means electrons absorb the photon energy and those will emit with some kinetic energy. But here, so what happened means if any light is incident on a some metal surface means so what happened, electron will be ejected from the metal surface as well as some that remaining, so that means some photon also scattered from that material. Okay, so previous that, so total whatever the in case of photoelectric effect, so all photon is absorbed by the metal plate. Here some only some energy of the photon is absorbed, so remaining, so that means here wavelength is decreasing after collision. Wavelength is decreasing means frequency is decreasing. That means so that photon loses its energy. So initial energy is h nu, so final energy is h nu dash. Okay, so that means so after collision what happens, some energy is lost. So some energy is lost means what happened, that energy means so that energy is absorbed by the this electron, and this electron will be so will get some energy and recoil. So electron will become recoil. Okay, so this is the here Compton effect. Okay, first we will discuss about the what is the statement here. Yeah, so Compton observed that when monochromatic beam of high frequency, that means lower wavelength radiation, is scattered by a substance. The scattered radiation contains two type of wavelengths. Scattered radiation contain two type of wavelengths. Okay, so now what are the two types of wavelengths we will discuss. Okay, so first one having same wavelength, that means here, so after, so one light is incident on the substance here. So what happened, either without collision, suppose on the way there is no electron means, so it will come directly out. if on the way there will be electron will be there means, so that photon will be scattered with that electron. Okay, so some energy gives to the electron and some remaining by using remaining energy it will be scattered. It will be scattered. Okay, so that means here, so either two photons will come out. So one photon does not change any energy. So one photon change some energy, some change with some energy. Okay, so that means we are discussing about only so whether the photon is changing, how much energy is changing. Okay, so unchanged photon we are not discussing here. Okay, understood here? See here, so yeah, so this is the so one substance. Substance means here in that substance so many number of atoms will be there inside nucleus, and outside electrons will be there. So photons, so many number of photons are instant on here. So many number of photons are instant here means, so only some photons are scattered and their energy will become less. So some photons will come out as easily. Some photons will come out as easily. So that means some photons energy does not change. Some photons energy does not change. What is the reason means? Some photons does not involve in a scattering process. Does not involve in a scattering process. So those will come out as easily. So whatever the photons are involved in a scattering process, so those energy will become less. Those energy will become less. Energy is less means what happened? Wavelength will become high. Wavelength will become high. Okay, yes. So this is the definition here. So that means one having the same wavelength as that of the instant radiation. Whatever the instant radiation will be there, so one photon have same energy. So while the other having the wavelength greater than that of the instant radiation. Other have the greater than that of the instant radiation. That means other frequency. So this, if you will observe this, so energy is less means, so wavelength is high. Wavelength is high. So this effect is known as Compton effect. This effect is known as Compton effect. Okay. Now coming to the, see here. So Compton scattering. So here photon is instant on that. So that means that photon is so that means collide with the elastic collision with this electron. Elastic collision with this electron means, so this electron is recoiled from the atom, and so remaining photon, that means here photon loses some energy, remaining photon will be ejected like this. That means your, suppose your initial wavelength is lambda, so after collision, so this wavelength will become lambda dash. So there is a change in wavelength, so that is lambda dash minus lambda, that equal to wavelength shift that equal to del lambda. So del lambda equal lambda dash minus lambda. So by using this experiment we will calculate this value. Here. Yeah. See here. So observe this motion picture. See, photon is instanting on here. So one electron is ejecting like this direction, and photon is so coming like this direction. Okay, understood? Now coming to the explanation. According to the quantum theory, when photon of energy h nu strike with the substance of sum of the energy of the photon is transmitted to the electron. Okay, according to the quantum theory, when photon of energy h nu strike with the substance of energy of a photon, is transferred to the electron. Energy of the photon is transferred to the electron. Okay, understood? So when photon is instant on the substance, what happened? Some energy of the photon is absorbed by that substance. So substance containing so many number of electrons. In that, any electron absorbs that energy. Okay. Now, therefore, the energy of the photon is reduced. Energy of the photon is reduced means wavelength will be increases. Here, So we have to assume some assumptions for explaining the these Compton effect. So what are those assumptions? Means the collision is relativistic. The collision is relativistic and elastic. Elastic collision. Relativistic means, what is the meaning of relativistic? Means if you observe according to one view, it will be that point is correct, but according to another view, it will be may wrong. So that is the relativistic. Okay, according to one observation, so that ethic will be, suppose if one instant will be good, right, according to another view, so that instant will be wrong. So that like that, so the collision is relativistic here. Collision is relativistic and elastic. Elastic. Elastic is nothing but elastic collision is nothing but movement of energy is conserved, and energy is conserved as well as momentum also conserved. Energy is conserved as well as momentum is conserved. Then it will call it as elastic collision. Elastic collision. Okay. So that means first assumption is the collision is relativistic as well as the collision is elastic collision. Okay. Second one, the law of conservation of energy and momentum hold good. Okay. So elastic collision is nothing but conservation of energy as well as momentum is that means conserved. Now coming to the so first here, so incident photon having certain energy h nu. So this is the photon is instant, and here that photon energy is h nu. Okay, and so momentum, what is the momentum of photon? So generally, what is the momentum in case of any particle? So momentum will be like that. So P is equal to m into v. M into v. Here we are taken photon. So we cannot define the mass of the photon. Okay, that's why. So here, so that means E is equal to energy of according to the Einstein. So there is a relation between energy and mass that equal to mc square. E equal to mc square. But according to the photon energy is equal to h nu. So mc square equal to h nu na. So that means here mc is equal to h nu by c. mc is equal to h nu by c. So mc is nothing but momentum of the photon. So c is the light velocity. So m is the mass of the photon. So so we cannot define the mass. That's why here, so by using photon energy, so we are calculating the momentum. So p is equal to h nu by c. P equal to h nu by c. So how we will get this formula means, so mc square, already we know that, and according to Einstein, so conservation of energy E equal to mc square. So that equal to h nu, mc square equal to h nu. From that, so bring the c one c like this direction means mc is equal to h nu by c. So that means mc means, so that is the momentum of the photon. So p equal to h nu by c. Okay. Now coming to the, so this is the momentum of the photon. Okay, when it will be means before collision. Okay, so what is the energy of the photon? H nu, that is before collision. Okay, now so here collision is occur between the electron and photon. Collision is occurring between the electron and photon. Okay, so now, so initially, so electron is at rest. Electron is at rest. So electron is rest means, so what is the momentum of the electron? Zero. Momentum of the electron 0. Okay, now so here, so finally what we will get the momentum means p is equal to mv after collision. So electron will get some velocity. Electron will get some velocity. Electron have some mass now, that equal to m. Okay, so finally p is equal to m into v. M into v. That is the, what is that, after collision momentum of the electron. Momentum of the electron. Okay, now after collision, what is the energy of the photon means h nu dash. H nu dash. So what is the momentum of the photon means, so p dash equal to h nu dash by c. Okay, so that means here nu dash means change of the frequency. So frequency will be decreases now. So initially frequency will be high, so after collision frequency will be decreased. Okay, so now here energy equal to h nu dash, momentum equal to p dash equal to h nu dash by c. Okay, now the energy of the system before collision. Okay, so energy of the collision, so that means h nu plus m naught into c square. M naught is the mass of the H nu is the here before collision there is both, so electron will be in rest, electron will be in rest, that's why. So here m naught we will take rest, electron rest mass energy, electron that means m naught is the sorry mass of the electron, m naught is the mass of the electron when it will be in rest, when it will be in rest. Okay, so m naught into c square, that is the energy of the electron when it will be rest, when it will be rest. H nu is the mass of the photon. So what is the total energy means H nu plus m naught into c square, that is before collision, before collision. So total energy of the system equal to H nu plus m naught into c square. Okay, now the energy of the system after collision, after collision. So after collision, so what is the mass of the electron means m, here m is the mass of the electron when it will be moving, when it will be moving. Okay, so now according to, so that means so mass will be changes while according to the motion. So that means so based on the Einstein relativistic theory we can explain the how mass is changing, how mass is changing if particle is moving with relativistic velocities. Relativistic velocities means that velocity should be approximately equal to the light velocity, approximately equal to the light velocity, then only we will consider. So consider that, so while particle is moving, that mass also changes, that mass also changes. Okay, so that means if particle is moving with light velocity means mass will also changes. So that's why here we, yes, before collision. Yes, who is that? Okay, now before collision h nu is equal to m naught c square we are taking. After collision, so photon energy equal to h nu dash, so electron energy equal to mc square, mc square, according to the principle of conservation of energy, according to the principle of conservation of energy. So what is that? So before collision energy is equal to after collision, before collision whatever the energy is equal to, so after collision that means energy is conserved, energy is conserved. So whatever the energy before the collision, that is equal to the, so whatever the energy after collision. So that's why, so we are equating these two equations, we are equating these two equations. So h nu plus m naught c square equal to h nu dash plus mc square. Okay, so from this we are calculating mc square, mc square equal to, we will bring this term this side, h nu minus h nu dash plus m naught into c square. Let us take this is equation number 1 and square both sides to this equation, squaring both sides to this equation. If you squaring both sides means this will become m square c power 4 is equal to, so this is a minus b plus c whole square, a minus b plus c whole square, that means a square plus b, a square plus b square plus c square, c square minus minus 2ab plus 2bc. Okay, so plus 2ca. So here we are taking, so nu minus nu dash is common. Okay, so sorry, 2h m naught c square is common in these remaining two terms. So it will become nu minus nu dash. Okay, so by using a plus b plus c whole square, by using a plus b plus c whole square, so we are expanding this total term, we are expanding that total term. So a plus b plus c whole square, that means a minus b plus c whole square here. So what is the abbreviation of that means, so a square plus b square plus c square plus here b have minus, that's why minus 2ab, so plus 2ac minus 2bc, 2bc. So if you substitute those terms here means we'll get this equation, we'll get in this equation in that those two terms here 2h into m naught c square is common. Okay, if you will take common means nu minus nu dash we will get. Okay, so this is, let us take equation number 2. Now coming to the, according to the principle of conservation of linear momentum, according to the principle of conservation of linear momentum, so momentum also conserved, momentum also conserved. Okay, so here we'll take conservation of momentum in two directions, two directions. So one is the photon incident direction. Okay, that means actually photon is moving like this direction. So that photon motion we can divide it into two parts. Okay, so one is the horizontal direction. That means so the direction is incident direction. Another one is the vertical direction. Another one is the vertical direction. Okay, so that means horizontal direction we can take it as a v cos theta. So that means velocity is divided into two components. So one is the vertical component, another one is the horizontal component. Okay, here, okay. So before collision, what is the momentum? So see here, before collision, what is the momentum here? So total momentum, so h nu by c. So here electron is at rest. Electron is at rest means what is the momentum of electron? Zero. Okay, before collision, what is the momentum? P equal to h nu by c plus zero, plus zero. Okay, so that is the before collision. So the direction also along the direction of a photon direction. That means horizontal direction. Horizontal direction we are taking. Horizontal direction. So h nu dash by c into cos phi here plus mv cos theta. So why we are taking here? So phi means, so that means photon making with some, so here this is the horizontal direction. Photon making an angle here phi. Electron making an angle here theta. Theta for virginal direction. This is the actual direction of the photon. Because of the collision, what happened? Photon will move like this direction, electron will move like this direction. So electron is making theta with the original direction, and photon will making an angle phi to the original direction. So that's why here, okay, so h nu by c into cos phi, so plus mv cos theta. Okay, so cos theta means, so this direction is along the horizontal direction. Horizontal is direction is nothing but, so initial direction of the photon. Okay, so from this, so mv cos theta, so that means we will bring the c this side, so what happened? So c gets cancelled here, c will be multiplied, so that's why mvc cos theta here. Okay, so mvc cos theta is equal to h nu minus h nu dash cos phi. Okay, let us take this is equation 3. Now, so one more direction means, so that is the vertical direction. So that means before collision there is no vertical direction. Before collision there is no vertical direction, only horizontal direction will be there. Okay, so that's why, so in case of vertical direction, so before collision there is no momentum. So after collision, see here, after collision here, so that means v sin theta we can take now. Velocity is divided into two components, so one component is v cos theta, another component is v sin theta. Okay, here also, here this component momentum also divided into two components here, so that is the, so p dash cos theta and p dash sin theta. P dash cos theta and P dash sin theta. P dash sin theta is the vertical direction. Okay. So instead of P dash sin theta, we are writing h nu dash c by sin phi. Okay. So that means here we are taking angle is phi. That's why we are taking angle here phi. And minus mv sin theta. mv sin theta. Okay. This is after collision. After collision. So what is the momentum? What is the momentum? So why we are taking minus direction means, so if you divide it into two components, this direction is like this direction, so electron is moving like this direction. Okay, electron is moving above direction, but photon is moving below direction. If you will take two component means, so one component is like this direction, so another component is like this direction. So one here also like this direction, and so like this direction. Okay, so horizontal directions are both are in same direction, but vertical directions are, so electron direction is opposite to the photon direction. So that's why here we are taking minus. Okay, so before collision what is the momentum, after collision what is the momentum we are taking. Okay, so before collision in vertical direction momentum is 0. So after collision, so that momentum will be like this. Okay, from this, so mv c sin theta, if you multiply this direction means mv sin theta equal to h nu dash into sin phi. This is equation number 4. So from these 3 and 4 equation, So what we are doing means, so both equations we are squaring and multiplying, so adding. Okay, so both are we are squaring both sides. Yes, who is that talking? Who is talking here? Okay, now we will go further. Okay, so now there is a equation 3 and 4. So squaring equation 3 and 4, adding both. Adding both. Who is making noise? Okay. So that means here, if you observe this, so both equation 3 and 4, we are squaring and so adding both. So if you will get, so mvc cos theta square plus mvc sin theta whole square. We are taking mvc whole square is common. So if you will take common means cos square theta plus sin square theta. Cos square theta plus sin square theta means it will become 1. It will become 1. M square v square c square is equal to. So here, so remaining, so in this direction, if you add both and square it, add both and square it. So if you simplify this equation, we will get the equation 5. We will get the equation 5. Okay, let us take this is equation 5. Now, so there is a equation 2. So this is the equation 2 here. And so this is the equation 5. So subtracting equation 2 from equation 5. Okay, so that means if you subtract means m square c power 4 minus m square v square c square, m square v square c square. If you subtract both means we will get here.
Sir, M4 is talking. M4.
M4, huh? Yeah, M4. Why are you talking?
Yes, sir.
Why are you doing like that? M4. M4, respond once. M4. If you do like that means I will remove you from in class. Okay. Yeah, now so if you do that, see here, so by using equation 2 and 5, by using equation 2 and 5 here, so equation 2 is this one and equation 5 is this one. So subtracting equation 2 from equation 5, so this is the 5. So if you subtract both equations means here, so we will get, yeah, so these are some terms will be there, so these are some terms will be there. So if you subtract yourself, some terms will be cancelled here, some terms will be cancelled, you will get the equation will be like this, you will get the like equation will be like this. Okay, so now here what we have to do means we have to subtract the, so instead of m naught we have to subtract m value. Okay, for that what we are doing means according to the relativistic mass, that means Einstein relativistic theory will be there. Einstein relativistic theory will be there. So according to that theory, so mass also will changes. Mass also will changes if particle is moving with a light velocity, approximately light velocity. Approximately light velocity. What happened? Mass also changes. Mass also changes according to that. So change of the mass m equal to m naught is the rest mass energy. If electron is at rest means that mass energy equal to m naught. Okay, so change mass equal to m equal to m naught by under root of 1 minus v square by c square. Okay, now so from this, so m naught square equal to, so we can get m square into 1 minus v square by c square. So if we simplify this equation further, so multiply inside m square, uh, m square into c square. Okay, and so m square into v square. Okay, so here there is a common c square, so you can send this side means m naught square into c square. So we will get this equation, m square c square minus m square v square equal to m naught square into c square, m naught square into c square here. So again multiplying with c square. again multiplying with the c square. Okay, so if you multiplying c square means m square c power 4 minus m square v square c square is equal to m naught square into c power 4. This is equation 7. This is equation 7. Now using equation 6 and 7. So before this is the equation 6 here. Okay, so in that m square c power 4 is say. So in that m square c power 4 we are substituting this value. We are substituting this value. Okay. So otherwise m naught square c power 4 will be there. So in that m naught square c power 4 we are substituting m square c power 4 minus m square v square c square. Okay, if you substitute, so this m naught square c power 4 value in this equation, so what we will get means so these two terms will become cancelled. These two terms will become cancelled. So that means see here. See here. So this value will become same to the so that left side value, LHS value. Okay, so that's why this term will be cancelled. So that means here final equation will be it will be 0. It will be 0 into, so what is the remaining will be the 2h nu into h nu dash into cos phi minus 1 plus 2 m naught c square into h nu minus h nu dash. Okay, so that only here remaining. That only here remaining. Okay, so now if you bring this term this side, okay, this equation will be like this. This equation will be like this. So again here, so we are taking h is common. H is common. Okay, so yeah, so if you simplify here, 2 will get cancelled. Remaining is the m naught c square, and if you will take h common, so if you send, okay, and here, so this side h will be there, so 1h will be gets cancelled with each other. 1h will be get cancelled with each other. So bring that nu and nu dash this side. Okay, so that will become nu minus nu dash by nu dash. Okay, here what is there? 1h it will be there. So bring that m naught c square this side, h by m naught c square into 1 minus cos phi, into 1 minus cos phi. Okay, so this is okay. Now if you simplify this, so it will become, so it will be divided into individually. So that numerator is divided into individually. So nu gets cancelled, 1 by nu dash. So here, so nu dash gets cancelled, 1 by nu. So 1 by nu dash minus 1 by nu equal to h by m naught c square into 1 minus cos phi. Okay, this is in, so in terms of frequency. This is in terms of frequency, but we have to convert this in terms of lambda. So we know that already frequency, there is a relation between frequency and lambda. Mu is equal to frequency is equal to c by lambda. Okay, if you substitute that value, we can get so lambda dash minus lambda equal to h by m naught c into 1 minus cos theta. Okay, 1 minus cos theta. If you substitute the, so this relation, if you substitute the nu and frequency relation, so we will get, so lambda dash minus lambda equal to h by m naught c into 1 minus cos theta. This is the Compton shift. This is the Compton shift. That means there is a change in frequency between the, so both. Okay, now time up now. So just I will take the attendance and then so remaining we will discuss tomorrow. So wait, I will take the attendance here. One minute. Yeah. So if anyone have any doubt means you can ask. Any doubts? Yeah, otherwise you can leave.
Thank you, sir.
Yeah. So just read once. Okay, then you can understood. Okay, this is total problematic. So just you practice once. You practice once, then you can understood the steps what we are doing here. Okay.